Okay. Now our second presentation in the category of innovation in rail and transit is the Hallandsås. No, what did it do? Say it for me.
Hallandsås.
Okay, Hallandsås. My Swedish is not too good. Hallandsås Live BIM Railway Project. And it's being presented, and if I say this name correctly, it's a miracle. If I don't, he'll come and correct me. Our presenters are Daniel and No, okay. Well, I got up on the toes like you showed me. On her. Okay. Okay, new names for me, okay. Daniel. Okay. Okay. Technology strategist, Leaf Mom, technology strategist for large projects, and Kenneth Russell. Close? Okay, good. Okay. Project manager. Gentlemen? Wait, just a second. This is a $1.5 billion BIM project from Förslöv to Båstad. Did I even get close? Okay, all right. Sweden. Thank you very much.
Thank you.
Daniel.
Thank you. I would like to start, welcome you to this presentation. There will be some kind of Swedish English in this session. I would like to start by saying thank you for this opportunity. We are really excited to be here, both to listen what other projects and experts are working on, but also to tell you about our project. Let's start with today's presentation, the Hallandsås Live BIM Railway project. Let's see. By my side today, I have two gentlemen from the Swedish Transport Administration.
Yes, I'm the project manager for the tunnel, the client's manager for the civil works in the project.
Okay, I'm Leif Malm. I'm working at the technology department, major projects in the Swedish Transport Administration. The Swedish Transport Administration is 2.5 years old. It's a fusion of rail administration and road administration that happened 2.5 years ago. We have been using MicroStation since I started in rail administration, and I was the first user of InRail in Europe, I think. I was project leader of team from Sweden when we started that 1991, I think. We have used what's called ProjectWise since year 2000 in the railway. And now we introduced it for the rest of the company administration. I'm architect for the introduction, and I'm architect for using building information models for transport administration design work. Thank you.
Let's have a look at today's agenda. Kenneth Russell will briefly discuss the background of this project and where we are today. Further, Leif Malm and myself will talk about BIM in a variety of uses based on these questions, like you can see here. Why BIM and how we have defined it, what we have done and what BIM has helped us to overcome, how we aim to use BIM through the rest of this project, and what the short and long-term gains are for the project and the construction industry. So, go ahead.
Yeah, thanks for the opportunity to present Project Hallandsås in this forum. Okay. The project is a part of a comprehensive modernization and a powerful expansion of the capacity of the West Coast Line. The West Coast Line is one of the main lines between the second and the third biggest cities in Sweden. It is also connection in north to Oslo and in south to Copenhagen via Öresund Bridge. One part of the modernization is to remove level crossings, which causes almost all the accidents. West Coast Lines still lacks a few parts, and one of the most important is Hallandsås. Hallandsås is a tunnel project with each near 9 kilometer long single tracks. The tunnels will replace the existing curved and steep railways from 1885. The capacity will rise from 4 to 24 trains per hour. The tunnels go through a bedrock hoist that rises over 200 meters or above the sea level. The ridge was formed about 80 million years ago and has been strongly influenced by tectonic movements in the Earth crust. These are our technical challenges in the project. We have a large variation in rock quality, from very hard rock to completely weathered rock. We must construct waterproof tunnels that can handle over 150 meter water pressure. We have restrictions regarding the leakage of groundwater. The land on the surface is very sensitive, so we are not allowed to leakage water. The project started in 1992. Due to the technical challenges were underestimated, wrong decision was made regarding construction. When the impact on the environment became too large, the project was stopped in 1997, and it was stopped in 7 years. Between 1992 and 1997 was 1,200 meters of the tunnels in the north and 1,700 meters in the south excavated. When the project was restarted in 2004, it was decided to use a new technique for Sweden for tunneling. We decided to use a customized, powerful, shielded tunnel boring machine, TBM. It has a diameter of 10.6 meters and a possible thrust force of 19,000 tons. The tunnels are lined with 54 centimeter thick concrete segments that also can handle the water pressure. These segments are installed inside the TBM shield, and with this technology becomes the tunnel sealed, and we can build tunnels without causing any long-term impact on the environment. The tunnel construction is carried out by a joint venture between Skanska of Sweden and Vinci of France. This work is carried out as a design and build contract. Work is carried out all the hours and all the days. Due to the history of the project, much effort has been spent in order to create a systematic way of working regarding environment, working environment, quality, and risk. This picture shows the current situation for the project. The eastern tunnel, in the eastern tunnel is excavation and the concrete lining completed. In the west tunnel remains next year. The most difficult part remains, including a very bad zone of 230 meters with weathered rock, and this zone is supported and pre-treated with man-made freezing. While the tunneling taking place in the western tunnel, work is carried out also with the cross passages. There are 19 cross passages to be built with waterproof concrete lining. The total budget for the project is 1.2 billion euro. The tunnel with the TBM, tunneling with TBM will be completed in the end of 2013. The cross passages will be completed in early 2014. And and the planned traffic start is in the end of 2015. It will be a challenge to meet this schedule. Great demands are placed on on the coordination of different designers and contractors. And the project has been in need of finding an effective tool for coordinating the as-built information as well the design information. This is the main reason for our decision to use a 3D building information model. Yes.
Transport Administration Building Information Objectives. We have the objectives to lead the development of virtual design and construction in the infrastructure area in Sweden in collaboration with the market. We work together with design engineers, building contractors, software delivers, and we have an open BIM consortium in Sweden, where all those are over 100 partners in this. To use the building information models from design to maintenance and asset management in all stages from preliminary studies, planning, detailed design, actual building to as-built information. And in the end for maintenance and asset management. That's one objective that's very important. And the head of the administration has said that all investment projects should use building information modeling to some extent, on some level, in the end of 2014. It's a decision. So,
and let's go further with the project's objectives. The project's objectives is very much based on how do we ensure the timetable. We are deciding at the same time as production. So we need to have an effective BIM process to optimize the production. We also have to use BIM through several stages to achieve the benefits of really thinking big. And we will create models with integrated information and also work a lot with the coordination and collaboration in the project. BIM within the Hallandsås project is essentially based on the virtual design and construction theory, with a focus on working with a couple of processes and implement a way of thinking and using BIM in the organization. That's a pretty hard one, I can say. And even to design a product that is like a one concept model prepared for a variety of uses in process. As you can see below, there's a definition we have taken from the Stanford. And that's pretty much the base in this kind of thinking when we're using BIM. Yes.
Why BIM? Benefits of BIM, we hope. Increased quality throughout the entire life cycle. The information of the construction or an object can change throughout its lifetime, and the quality of the information can be increased. The same happens in the different stages of a project. Easier to reuse the information. We use ProjectWise. We use the information in the model. We share the information. You can reuse it all the time, and you can also connect with other projects. Increased design quality and improved design. We hope it happens. We think it happens. We think we can reduce our contractors with 10%, the contracts, with a better information, more quality on the information. Increased quality of the built facility, I hope, and we think that the documents, the BIM methods, automatic or digital communication increase the quality of the facility information. And we are going to use Bentley transmitter service for that, Marks. Continue. Efficient and effective information management across the whole life cycle. We have control of costs. That's very important for these big projects. Reduction of risk. We can find if there are risk problems very early in the project. Visualize model facility communication Also, if you have with other communities, you show the visualization of the model, and you minimize the problems. All design fields combined in one model. Of course, that's a very important thing, but ProjectWise use shared models handling with MicroStation and other software. Mistakes are detected earlier on the process. Of course, clash detection is one important thing, and how things connect to each other. Easier to detect the impact of change. If you change anything, this shall be visualized as soon as possible for the rest of the team. Up-to-date asset management data by updating as-built information. Today we have about 3,000 users in Sweden or ProjectWise, so we have detected it already. It is very important for this very delicate problem with Hallandsås.
Since initiation of this portion of the project since 2010, all disciplines and suppliers have been required to follow comprehensive 3D design guidelines to specify the delivery formats, quality and contents, so that the model can be adapted for a variety of uses, like working from the models to drawings, of course, we're trying to minimize the drawings, put out the models into the production, of course, one big thing, and you can see that there's a lot of things to go into. Achievements. I should say that we have worked with a lot of different kind of softwares here. You can see it's from MicroStation and the InRoads and ProjectWise, of course. That's a big part. And there's a lot to say about the 3D design and the BIM technology with support of Bentley software. So we have worked a lot with when we are doing the 3D objects to connect them to the old drawings and the 2D models and stuff to ensure the quality. We have done a lot of scannings in the tunnels and light them up, if you can say so, so we can handle it in the CAD models. And we'll also work with advanced parametric designs in InRoads. Here you can see an example for this. And even the Kant functionality and these abstract models. It's like which describes the requirements and standards for free space. The coordination process with continuous meetings helps us to collaborate and coordinate all models. The first thing is that the BIM manager in the project, gets the delivery from our suppliers, of course, in ProjectWise. And we are receiving it and updating the coordination model, like a receiving inspection. And then we are doing a pre-inspection of the model, including the design checks and clash detection. And this is sent out before the meeting. And we can deal with the problems before the meeting, and we can go there and solve problems instead of going there and get to the long to-do list. So this is a pretty important thing. When working in the coordination process, we have used several basic functionalities like clash detection and the coordinating section cut. That is a section that cuts through all graphics. It's a dynamic view functionality. We even use the 3D PDF, which will be moving here. Oh, it does hit on this screen. Yeah. We even use the 3D PDF to spread the model to everyone in the project without need of an installation. Everybody got the expert reader. So that's something we use a lot. We have also worked with content analysis. This is an example of the TBM generation of the as-built models to be able to manage the engineering design. The process starts when we are collecting survey data from the contractor of the as-built models. the TBM positioning of the rings in the tunnel. In a combination between the survey data, the scripts, the object library of the rings, we can generate a the TBM rings to an as-built 3D model with the right kind of insertion point, the gaps and the roads, and, you know. Then we will compare it to the engineering design and abstract models. In the combined master file, we can do section views of all interest places with a dynamic views, and also generate drawings to support critical decisions. Using an example from a couple of months ago during the construction, the TBM was outside the tolerances. So we used the TBM generation process here to understand the impact of what's happened with a predicted version of the generation. You can see the difference here between the as-built model and the engineering design in this section here. So we can see this before it even happened. That's what I call live BIM, when you can connect it that way. The red zones, pretty dark here, but the red zones you can see here is the reinforcement zones. So we can see where to put our engineering design of installations. 3D object library based on type drawings with integrated information gives us a lot of opportunities. The objects are described by volumes with a definition point, and we have done like 300 until now. This is an example of a PDF with an embedded 3D model, integrated information, and a couple of links. This is, I don't know what you're calling it, but buffer stop, or in Swedish, stoppbock. It's based on 12 type drawings, and you can see all kind of attributes in the list here. These objects, which is stored in a cell library, are also free for use for all railway projects in Sweden by whoever wants to work with 3D design and BIM. The industry can now download them from the website of the Swedish Transport Administration. The integrated information contains 3 links to several different uses. Part number linked to the product information and the specification codes and type drawings. This is very useful. BIM in the next stage. BIM models prepare for further operations. Our BIM models are prepared for further operations, especially in the construction stage, but even for operation. We will work with survey layout where coordinates for a wide variety of objects will be used directly from the model. Machine guide and machine control is also something we will work with. Our creative line strings model will go out to this with a focus on where we have put some focus on the model structure, the way it's coded, and how to ensure the quality so that we can be sure that it will work in any machine system on the site. In the bottom you can see the AR, augmented reality, which is technology technology we have been working with the last year. It's a virtual design model augmented with reality, as you can see in this image. Very useful. Yeah.
Return on this innovation we have done. We have used Hallandsås as a test project. We have 5 more big test projects, very big. We use very big projects as test, and a lot of them. But the collaboration of the working process, we are results in standards and working methods for further projects. Integrated design environment in ProjectWise, all technical disciplines in ProjectWise, which means calibration, and in Swedish Transport Administration, this will be the standards for investment projects for rail and road. And we are going to impact it next year, more or less, starting the implementer, the big implementer. Reuse of all the design parameters. If you're going to work with railway projects, you're going to work with those design parameters that we offer, because that's what they want for the administration and the maintenance in the end. So they shall use the 3D object library, they shall use the templates, they shall use the level library, and so on and so on. It's, they have to do it, and we put it now so it's made accessible for all other projects to get it from the homepage website from our company. I think it's very important. It saves money.
So thank you again for this opportunity. We hope you have enjoyed this presentation, and that will inspire you in your future projects. If you have any questions, I will be happy to answer them. We will be happy to answer them now, or you are welcome to contact us later. You can even pose questions to Mattias Skog, Virtual Design and Construction Manager at Sweco Infrastructure. Yeah.
Okay. Kjellstevik, Nordic Infrastructure Magazine. The boring process in Hallandsås has taken a very long time, as we know. But my question is, if BIM was integrated in the project much more earlier, do you think the project would be finished faster?
No, it's not that question. It's about the environmental impact that happened. You know, they use rock argil that polluted the water.
Colin Everson from BAM Nuttall and Railway Civil Engineers Association. You discussed about the use of BIM by the end, I think, of 2014 for projects. Is that just transport projects, or is that government projects as a whole? And also,
rails and roads. It's for rails and roads that we, the government, have.
and also the extent that it's used. Is it left to the particular contractor and designer to define, or is there some definition that they must?
We are the client for over 30 billion Swedish crowns each year for building and maintain rails and roads. 30 billion Swedish crowns.
So the question was about the use of BIM. Do you define to what level that they must use it for each project?
Yeah, we are taking out different, I think there will be 3 levels of building information modeling. That's what we produce in-house.
Next question.
Yeah, sort of with the earlier question, would the project have gone on without BIM if it hadn't been mandated? Or did the mandate sort of force you to reassess things and work in a little different methodology than you would originally have done?
We used ProjectWise from the beginning, from our year 2000 in the project. That's the first step we made. And in railway design, we had some BIM concept from the beginning, since '94. So we have used some concept of BIM for railway all the time. But now we lift it higher up in the level. So level 3, the highest level, is Hallandsås.
Anthony Oliver from New Civil Engineer. I think you have to be congratulated for your staying power on the job. It's certainly it's epic and heroic, the effort you've been putting in since '92. But I suppose, how difficult is it to implement a BIM project? I suppose almost retrospectively. You've been going so long. Are you trying to play catch up? And I suppose how does that impact the other 4 test programs you've got going, or the other test projects? Are they using BIM much earlier, to much greater degree earlier in their jobs?
In the railway part, we introduced this with the different technical model files and using ProjectWise very early, the same techniques very early, but it wasn't named BIM. There was no name on it. The BIM name it came a couple of years ago. We didn't know that it was named something. But the concept we used from the beginning, since '94, '95 about it, and even the road did it on their part. We had different software or so. But all infrastructure projects more or less use some degree of information modeling. Has done that for many years. I think you know that. You have used models, you have used technical models, and you have more or less could work without maps, without drawings. You could setting out data directly from the models and so on. So it's about but we do now make it more conceptual common methods for using it, and try to have the market to using the same idea that we introduced together with the market.
And what input does Skanska and Vinci, obviously they're big international global companies, what input do they have into your development in Sweden of BIM technologies?
Skanska is the great contractor in Sweden, and they, together with Vinci from France, had an idea about these TBM methods, because that failed before.
Specifically, what do they add to the BIM process?
Nothing at all. Of course not.
Survey data.
Survey data.
Yeah, of course, survey data, and we use it to compare it with the design. We're designing the installations, and that's what we're doing. But they are going into this harder now, because they have to do some, a few things by themselves.
So I'm a bit confused.
It's coming, Anthony. So I'm very intrigued by providing the content in the form of the cell libraries, but by way of 3D PDFs, I think you said, on the part of the Transport Administration, because ultimately that does come back to you to manage and operate, and that seems like a far-sighted notion to me. Is that a matter of some cooperation with the supply chain who manufacture these components and so forth, or have you had to?
Yeah, we got. I can see here on this screen. We have a lot of links to this kind of to the supply chain, where we can get information on the product information and stuff, weight and cost and delivery time and so on and so on. This is one of the things we can use.
That would seem to be a
stored
real.
in the cell library.
We have something that called the material servers on Transport Administration. They connect all the material for a railway, and they have their material code. Code is a part number you see there, so we can go in and order from the material service. It's a railway important material. You know, example, you know that the TSI, this is a material that is driftcompatibilitetskomponent components that are used in the railway for all Europe, but they supply them.
Well, it's a wonderful advantage I wasn't aware of, and will help ensure project quality throughout the life cycle, and maybe a precursor to the Bentley content services in Bentley Connect. Thank you.
I think Anthony, do you have one more question? We got time. You got to wait for the mic. I'm strict on this. I'm a hard time. Last one, Anthony.
Sorry. Can you just come over and sit by him?
Sorry, it's I probably missed something. It's the contractor is a design and build. They're involved in the design of the tunneling. That's correct? So
the civil works, the work with tunneling is design and built,
right.
but not the railway installation work.
Right. So,
Okay.
so my question was, what input? How do you interface with the design and build contractor throughout the whole BIM process? Are they integrated into that?
Yeah, in some way they provide us with the survey and as-built information.
Thank you very much.